So hello everybody. Welcome to our talk about our homemade bidirectional replication solution. So we are coming from Proginov, a company of 300 people in west of France. We published, host and integrate our own ERP solution in France and beyond. And we currently have 2 private data centers, and we monitor over 14,000 OpenEdge databases in production. So for those who don't know, we are located near Nantes, so a city with a great cultural history. So we have a famous Nantes castle, a famous art company, famous music festival. So if you are looking for your next holiday, come in Nantes, or if you are looking for a job. And let me introduce myself. So I'm Clément Brodu. I'm an OpenEdge developer at Proginov for 8 years now. I'm working on the framework of our solution. And I'm also in charge of all CI/CD stuff for OpenEdge in Proginov. And I'm working on several tools for developers in Proginov.
Okay, I'm Patrice Perrot. I'm an OpenEdge software developer since 2001. I'm working on optimization since 2005, and I'm a DBA since 2010. And feel free to ask questions when you want. A few years ago, we decided to use OpenEdge 12 in production. Like for the previous release, our tooling have to work on it. We need to centralize all data and metrics in a single point of access to have, for example, things like the load balancing for all ODB on our box. The compatibility is limited between 2 versions, not 3. So what was working fine with 2 versions, OpenEdge 10 and OpenEdge 11, will not work with OpenEdge 10, 11, and 12. So we have some homemade tools, like is a schema of them. All should work with all OpenEdge versions. We do not want to have people, colleagues, saying things that you are not using the good version, you will not see your results, so it's very boring to listen to this. So we have to have everything on all ODB. So during the last 10 years, we developed our tooling. There is a lot of screen, batch. There is 6 main DB and around 400 tables. So tools runnable from everywhere from ADBA, and data provided from everywhere also. And we are used to update VST in our process. So I have to do my job of primary DBA during those 40 days, because I have only 40 days before production. With more than 40,000 DB, it did not let me so much time per day. So our source DB also was around 1.5 terabytes, and I was not allowed to consume more than 2.2 terabytes. So we need a bidirectional replication.
So what were our options to meet our needs? Basic approach when we need to replicate data in OpenEdge is to use triggers, but triggers can be disabled with a simple disable trigger statement, so they are not reliable. And we also find them very complicated to maintain and to deploy, so we prefer avoid to use them. Another obvious solution when we talk about replication in OpenEdge is to use Pro2. But again, Pro2 was not suitable for us for several reasons. It's a unidirectional replication solution. So it's not what we want. We need to update the database schema of the tables we need to replicate, and we want to preserve the schema as is. And it's also based on trigger for OpenH10, so it has the same drawbacks as the simple triggers. Another approach would have been to use web service with a PASOE or app server, and to have a centralized backend exposing data to every OpenH version. But it was not possible for us because this implies to create a completely new architecture. We have to rewrite a lot of program procedures, windows that access to the 400 tables we want to replicate. So we will never have been ready in 40 days. So it was not possible. And we also have some programs that need to update VST tables, and some other processes that are based on logs, so it will not have been so easy to rewrite them. Knowing this, we choose to create our homemade replication solution. So setting up a replication seemed possible for us, and it allows us to just change a connected database at runtime, and we can reuse every existing program. The only challenge is to create a replication logic. So let's go. So what was the plan? The first step was to add a new OpenH 11 database in our architecture. So this database could be accessed from OpenH 12 process. And then we will have to create a batch process in OpenH 11 that can access both databases, so OpenH 10 and OpenH 11. And this process can replicate data and records between both databases. So the last step is to find change tracking tools that can provide us which records need to be replicated from one database to the others. So once changes are tracked, we just have to create a simple algorithm, a simple logic to replicate the data. So if it's we just have to, depending of the change type, we just have to retrieve the value of the identifying field, so the primary key that allows us to fetch the records in both databases if they exist. And if it's a create, we just have to create the records in the other database. If it's a delete, we just have to delete the records. And if it's an update, we just have to do a simple buffer copy to replicate every values. Be careful in case of update, the identifying field, so your primary key could have changed with this update, so you have to retrieve the before and after value of the changes. So now the only missing thing now is a change tracking tool. So this tool must provide three things: the type of change, if it's an update, create, or delete, and the before and after value for the primary key. So for OpenH 11, the obvious choice was to use OpenH Change Data Capture. So OpenH CDC, it's a feature designed to track every changes in OpenH database. And however, this feature is not available for OpenH 10, so we have to find another solution. Luckily, there is another feature called auditing that also allows us to track every changes in our database, but in a different way. So both features have similar purpose and operation. They both use policies to define what to track and how, but they have some differences. CDC, for example, can't deal with lob fields, so maybe it could be a problem. CDC has easy to read data because everything is stored in relational form. So if you track a customer table, for example, the tracking tables of CDC will be similar to the original customer tables. So it's very easy to query those values. And it allows us to create custom index if we need to. So CDC is quite a good option for us. On the other side, auditing can create many records per changing, depending of which fields you need to track. Data are stored in a custom form, so not very easy to deal with if you have to query those values. And data are stored with an American English format, so it's not always easy to retrieve the. You have to pay attention to that if you need to get the values. But auditing has a benefits. It's secured by design, so you have to grant every user that need to read or delete records in auditing tables.
So CDC. So it's very easy and fast to enable CDC when the DB is offline. You would just have to add these two areas in the DB and fire the -c enable CDC. And after this, there is some code source that Progress give in the community. You can find them. It's to enable the policy for a special table. In this case, it's for the table item. And as you can see, there is a CDC table, CDC change item that we called, and there is stored in these two areas. And we are setting some identify things, which is item num for item. So for every change on CDC, there is the CDC item table with all the fields with the underscore, which are fields of the CDC, and the other fields are the same fields as the table item. So each time a CUD occurs, there is one header, which is CDC change tracking, and there is also one CDC item, which is create. So now our source code is something like this. Based on the CDC change tracking, we are looking at the CUD, what is it? Create, delete, or update. Find is CDC table. Find the first record there, and the new and the old primary key. Find the record in the other DB, and do the update that we have to do.
So now we'll see how to enable auditing. So it's pretty similar to CDC. The first thing we have to do is to add two new areas in our tables, in our database, and then we have to run the putil command, passing the two areas name to the command. And then we have to load the default policies from the OpenEdge install directory, so from the file auditing /policies.xml. So once auditing is enabled, we have to define the policies for the tables we want to track. So in our example, we define a policy for the item table. We define a tracking level for each event type, so create, update, delete. We choose the minimum level because we don't want to store every value of every field of our tables. We don't need them. And then we define a policy for the identifying field. So here it's item num. And for this field, we also define a policy level, this time at a higher level, to store every value when this field is updated. We also define that it's an identifying field, and the order of identifying fields is in the event of there is many identifying fields for our tables. That could happen. We also have to grant the users that need to read or delete records in the auditing table. So here we granted the sync user to allow him to access to those tables. And then when we will make a change in our item table, this will add a new record in audit data VST. This record is a header that describes the changes. So there is two important fields here. The event ID that gives us the type of change, if it's a create, update, delete, depending of its value. And the event context that contains information about the records that have changed. So there is the table name here, so item, and the value of the identifying field, so 100 here. And if the identifying fields have changed, we also can query another table called audit data value that will store the old and new value as string, and this will allow us to retrieve the record of item later. So same way as CDC, if we want to retrieve all the information and do the replication, we just have to query every audit data records for our tables, and we can get the change type from the event ID and the old and new value of the identifying fields from the event context or from the audit data value. So now we have seen that it could work, so we have to move from a proof of concept to a production-ready solution. So we have to deal with some stuff. So the first thing we have to pay attention to is the log table entries. Like we said, when there is a change in our item table, it will create many records in audit tables or in CDC tables. So more records to write is more log to set. So we have to increase the -L parameter value. So we choose to increase it by 6 to avoid any log table overflow that could crash our application process. Another thing we have to deal with is cleanup of all our tracking tables. We don't want our database growth because of those tracking records. So we have to clean up records once they have been processed. So with CDC, it's easy because we just have to delete CDC records when the replication was done and when the record has been processed. But we can't do the same for auditing because auditing tables are VST and it's not possible to delete record of VST table from another OpenEdge version. And our replication process is in OpenEdge 11, so we can't delete records in an OpenEdge 10 database if it's VST. So our solution was to create a new OpenEdge databases to administrate all our replication solution. So this database will store every parameters information about our replication. And we add a new table in this database called audit to delete. And this table will store every IDs of auditing records that needs to be deleted because they have been processed. So we don't need them anymore. And we will run a new OpenEdge 10 batch process that will read this new table and delete the auditing records depending on the content of the table.
The CDC or the audit VST are part of the transaction that creates them. So if they are locked, the transaction is still active and can be undone. So it's very dangerous to replicate the CUD before the transaction ends. So if the record is locked, we will deal with it after. So the replication for an update in the OpenEdge 11 DB will create another update in the OpenEdge 10 DB. But this update on the OpenEdge 10 DB will create an update on the OpenEdge 11 DB. So it could be an infinite loop. It's not really an infinite loop because when you move back on the OpenEdge 11, there is no change in the field, so there is nothing which be updated. But it could be wrong because it's time-consuming to do a loop for nothing. And if you remodify the same record on your OpenEdge 11 DB, you will delete this update by transferring the update of the OpenEdge 10 in the OpenEdge 11. So we have to stop the loop at the first time. It's why every CUD which are done by the replication process is done by the user, sync user. And everything which is done by this user will not be replicated from one DB to the other DB. What I have also to do is I'm not allowed to have the same size for my 2 DB. So I have purges process, but on my new DB, which is an OpenEdge 11 DB, it must be smaller. For example, 3 months instead of 5 years. So I will use the same process, but I do not want that the 3 months purge go to the DB with the 5 years purges. So I do all the delete purges with the sync user, and there is no replication between the 2 DB.
So we also have to pay attention to the sequence because each database has its own sequence, so both databases could create records with the same IDs if we are in this case. So it could be a problem because if on one database you create an item car with item number 100, and on the second database you create another item bottle of wine with item number 100, when you will run the replication, one of those records will be erased by the other. And if the replication is still is already processing, you will have an error at runtime. So we want to avoid this. We want to avoid conflicts and data loss. So to avoid problem, we choose to increment our sequence 2 by 2 with, for example, even values for OpenEdge 10 and odd value for OpenEdge 11 that avoid problem. And we also create an option to resynchronize the sequence values to keep close value on both databases and to be easier for us to query our data. We also have to deal with our database schema because some of our tables don't have any primary unique index. So it's a problem because if we want to automate and create policies and scripts automatically, we have to retrieve the identifying fields automatically, and for this we are looking for the first for the primary key, the primary index, primary unique index. So we have to manually define which index should be used for this. So it should be unique index. We are not sure because it's there is no constraint in the database schema, but we know this index is unique. So we flag this index with a comment in the description of this index, and this will allow us to query the underscore index VST to retrieve each index we need to use, and this will allow us to generate every policies and replication scripts automatically.
Okay, there is a queue management because it's our DB that I use to manage all the DB at Proginov. So, for example, critical warning have to be in both systems very quickly. And daily metrics like CUD on the specific tables on 1 dB could be delayed for several hours. So depending on the criticity, the number of tables I have to deal with, I'm defining a number of process by, we'll say, level, and each table is associated to one level. So it allows me to have quickly my critical warning, and I can wait for the other records. So everything is stored in the replication DB. It's allowed me to run script to enable everything, to define my master DB and my slave DB, and set the policy, create source code, create new replicate set quickly. There is a screenshot of the element. And all the source code and object are versioning in this replication DB. It's allowed me to change the replication process event if it runs. Each replication process is running for 2, 3, 5 minutes and stop and restart just after. It's allowed me to change the source code enough quickly to be up to date of what I want to do.
So now we are ready, or we hope so. We'll see how to go to production. So at the beginning, we only have our existing database in OpenH10 database with some records. So this database is used in production. So many processes are reading and writing records in it. So the first step was to enable auditing on this database. So when a change will appear, auditing records will appear too. Then we create a temporary, we duplicate this database in a temporary OpenH10 database. For this, we use a ProBackup and ProS commands. This database is still used in production, so change continue to appear in this database. So new tracking, new auditing records continue to be created. But there are some auditing records that are already in the temporary database. So the next step is to remove them because we don't need them anymore. Those auditing records and the changes, their corresponding changes are already in the temporary database, so we don't need them. So we choose to remove them. There is other. We also process two other Proginov operations like convert to UTF-8 or database. To be easier, we disable auditing on the temporary database. This avoids to create new auditing records for nothing. Then we create our OpenH11 database. Then we import recent data for each table we need to replicate. So about, like said Patrice, about 6 months of data depending of each table. So we use a buffer copy, binary dump load depending of each case. Then we don't need our temporary database anymore. We enable the CDC on the OpenH11 database. And then we start. And finally, we started the replication that will synchronize every changes that appeared on the OpenH10 database since the first duplication. And the 2 dB will be synchronized. And then everything is okay, or maybe not. We have to deal with some reality. OpenH documentation said auditing and CDC can be implemented with 0 changes in our application, just configure and run. It's not that easy. Like I said before, one change with auditing and CDC will now create many records. So we will have the same problems as large transactions. So we have to make a few optimization.
Okay. Due to the new record of Audit and CDC, there is more activity in each transaction. So each transaction takes more time to end. And it's also transactions last longer. And until the transaction ends, there is no recycling of before image. So there is a lot of transaction active at the same time. So the before image file grow drastically with this. We have to take care about this. Yes, a small proof of concept on Sport 2000. I delete every record of order line in one transaction. And as you can see, the most logs, which is very interesting, does not change between OpenH10 and OpenH11. But with auditing or CDC, there is a very large increase of the most logs. With auditing, we are above 100,000, and with CDC, we are around 30,000 logs at the end of the transaction, which is due to the new record of audit and CDC which are created. So before, only one log at a time, now it's really huge. So instead of multiplying the dash L by 6, we multiply it by 40. We do smaller transaction. Instead of transaction per 1,000 record, we decrease it at 200. Another issue that we deal with, it's the index entry log, the phantom key. Replication process deletes many records of auditing and CDC. Progress let the phantom key of each of these records. And for example, on this case, as you can see, I read 1 million of index of CDC trend tracking sequence ID, but 0 record of this table. I have only placeholder in the DB for this table.
So it's also a good idea to reduce the number of changes to improve our replication solution. So there are many ways to achieve this. One of the options is to use variables. So in our example, we want to increase every order line by 10% and update the order total amount of our order. So rather than update the order total amount for each order line, so if you have 100 order lines, you will have 100 update of the order records. It's better to use a variable and update the variable and finally update the order once at the end. So you will only have one change instead of one change per order line. So it's simple, but it will improve the replication. One other example, you can use time tables. So here, rather than we want to update the total order amount for the customer. So for each order, we will sum up the value, the total amount of the order. So rather than update the customer for each order, it's better to sum up the total amount in a time table with one record per customer. And finally, at the end, for each record of our time table, update the customer once. So you will have only one update per customer instead of one update per order and of customer per order. And the customer can have many orders. And we can do even better here by using transactional packets. So this will allow us to use only one transaction for example, 500 changes. So it will not reduce the number of changes, but it will each transaction spends some milliseconds to be initialized, and use one transaction for 500 changes will improve and will be faster than the previous code, and it will also reduce the before image and after image consumption compared to a global unique two transaction block. And one last example, if you are using buffer copy in your code, in the old code we are creating item from a timetable. So we assign the item number from a function, and then we are doing a buffer copy to copy every other values. This will result of two changes. You can divide the number of changes by two changes per item. You can divide it by 2 just by using the assign keyword in the buffer copy statement. So you only have one change instead of 2 changes. So it's also a simple tricks, but it will improve the replication.
Oh, when I start this process, I have no time to analyze things. So I set everything to level maximum. So I store every change on every field. So it was time consuming for the replication process, because sometimes instead of having 2 records I could only have 1. So during 3 months, I analyze every change on this identifying fields. And in 3 months, I had never any change on identifying fields. I decreased the level from maximum to medium, which was faster on the process to create the record and the transition.
So maybe you want to raise our solution for your problems. So can it fit to your needs? You can consider it if you don't need to do high frequency update on the same record on both sides. So it's okay for profiler analysis or metrics or other stuff like that. But don't use it for critical data. It's still a custom tool. And you could have some synchronization issue because of our algorithm. Our replication process don't care about the chronological order of the changes. So it will just synchronize in one way and synchronize in the other way. So if you make a lot of changes on critical data in both sides, you could have some issue. But for our needs, we are not in this case, so it was okay for us. If you want some number, in the last 2 months, we measured an average of 16,000 records per minute with 50 replication batch session and 25 cleanup process. So it's just an average, it's not the peak rates of replication. And we probably could go faster, and the first limit we will have is network constraint, because today our databases and our process are running on different servers, so it's probably the limitation we could have one day, but today it's not a problem. The replication rate is enough for us.
Okay, so it was really fun to do this stuff. If you know how it works and how to achieve your goal, you will not consume too much time. For example, for me, it was around 60 hours to do everything from scratch to production. Because we are still active, even optimization, there is always performance issue to deal with, improvement on the queue, and there is also new tables that we have to add to your process.
So here's the result of our work, the final architecture with a new database for replication and the replication process and the cleanup process that are running. So thank you for listening. Feel free to ask any question if you have. We can do a little demo if you want, and if you need more information, we are here. Thank you. Is there any question? Yes?
One question, please. You started at the beginning with a temp table size of 1.5 terabytes, I guess.
There is, yes, my 6 dB was around 1.5 terabyte.
Yes, and when you activate auditing,
yes.
How was the increase of the size of the database?
It didn't change a lot. It was around less than half a gig because there is a process of purge. Each time, what you have to understand also, I'm looking for example, CDC trend tracking to know what's records to deal to transfer. But what I do not want is reread the same records to transfer it. So each time I deal with a record, I delete it. So it's not a large amount of data. And on audit, it's something like this. But so I'm looking on audit data, find the records, create a record on the other table. And in fact, what I do is looking audit data. Do I have to purge this record? Did I treat it previously? And if I treat it previously, next. So I do not want to have a lot of records because it's a lot consuming time to read data for nothing. So I delete them very, very, very quickly. So there is not a huge impact on the size of the DB. No more question? Okay, bye.
So we can just... oh. J'ai plus rien.
T'as un problème? Mettre.
Ça va bien. Okay. So just a little demo. So here we have two processes. So on the left you have an OpenH 10 procedure editor, and on the right you have an OpenH 12. So it's a simple example of our replication solution. So we have the same records in both databases. So here it's item 55, a surfboard. So if I update it from OpenH 10, it has been updated on OpenH, from OpenH 12, and I can do the same thing in the other way. And we have a surfboard 12 on the other side. So here it is. If there is no more question, it's so thank you.
Thank you.
Bye.